AI chats are powerful, but sometimes they're a bit too cautious. Let's build something with a bit more freedom. Using Mancer's API, we can work with less restricted models, customize our AI response, and choose the right balance for our need. In the next 10 minutes, you'll learn how to build this, fewer limitations and more possibilities. Here's our AI chat interface in action. And here's the cool part. You can switch between different AI models from Mancer, and each has its own style and capabilities. Here you'll see that each model has its own model name along with a number followed with a B. This stands for billion parameters. More is almost always better. It also depends on the training, but usually more is better. So watch how the responses change when we switch models. You'll need some basic React knowledge and a Mancer API key. And we'll also need Next.js, but even if you're not using Next.js right now, everything we'll cover is very easy to adapt. Let's get started. We'll break down the chat components, message handling, and API integration. Now, before we do that, we do need to get our Mancer API key. So for that, head over to Mancer.tech and sign up. Once you sign up, head over to the dashboard and you'll see that you won't have any credit balance. Now, what I did was I got the lowest package over here, which is $5. That gives me 1,250,000 credits, which is pretty decent. I've been using it roughly for around 20 days, just experimenting different things. And so far I've only used up about 500,000 credits. And it'll probably last me another month or so. It's pretty decent for $5. It's much more effective than, let's say, Claude or OpenAI. It's gonna last a very long time. Alright, so once you're here, just copy your API key and you're good to go. Alright, so let's break down our main chat interface component. So this component consists of three main sections: a header with a model section, a message display area, and a message input form. So the key features are that it's a real-time message streaming. We're using multiple model support. We're also implementing a smooth auto scroll. We're loading states. We are doing some error handling, and it has a TypeScript support. So let's talk about the state management. We're managing four essential pieces of state. First is the messages state, which is an array of chat messages. Next, we have our selected model state. This is the currently selected AI model. When the user first loads our interface, they will by default be using Xwin70B, which is the first model in our dropdown. The next state is generating, which is a loading state flag. And finally, we have the input value, which is just a text input value. Okay, so here we have our auto scrolling implementation. This ensures that the chat window automatically scrolls to the latest message using a combination of useRef and useEffect. Next, we have our message handling. The handle submit button processes the messages in three different stages. First, we immediately add the user's message to the chat so that the user can see it. Next, it will send a message to the Backend API, and after that, it will stream the response back in chunks to the user. So here's how the streaming implementation works. It reads the response stream chunk by chunk, then it accumulates the response text, and then finally it will update the UI in real time as the new chunks arrive. And finally we have the styling. We're using Tailwind CSS. By default we're using dark mode because I think dark mode just looks better for the eyes. I don't really like those bright lights, like the white styles. It's stressful to the eye. And finally, we are using a simple error handling over here. We're using a try catch error handling, and we're just catching the network errors and displaying user-friendly error messages. Now let's look at our model selector component. It's a very simple but an important part of a chat application. First, we have our model type and a list of AI models. Each model has two parts, an ID and the display name that the users will see. This ID is what we'll be using for our API calls. The component itself is pretty straightforward. It's just a select dropdown that takes two props. First is the selected model, and next is on model select. Selected model just shows which model is currently chosen, and on model select is a function to handle when the user picks a different model. Alright, so that was our front end, and now let's have a look at the backend. Okay, so here's the API route for our AI chat. Now, what we have over here is the API URL, which is the endpoint for the AI service, the API key, which is the authentication key, and the system prompt, which is the instructions for the AI model. Now let's have a look at the stream setup. So this setup over here, it basically just creates three things. First is the text encoder, which converts text into byte streams. Then we have our transform stream, which provides a writable stream that we can send to the client, which is our front end, and write stream, which is a helper function to format and send the data. Alright, so next, let's have a look at the API call configuration that we send to the API endpoint. So this is what will go to Mancer. So let's have a look at that. Okay, so we're sending a post request with these headers and our authorization key. In the body, we are adding this data. These are the parameters that we are using. The first parameter is, of course, the prompt, which is what we are entering, and it also combines the system instructions along with the user message and the assistance prefix. Next, we have max_tokens, which is the maximum length of response. 1024 tokens is roughly around 1000 words, 750 to 1000 words. You can change this, you can make it 2048 or something like that, depending on how long of response you want. Then we have our min tokens, which is the minimum length of response, which we are setting to 1. This gives control to the AI. Then we have temperature, which gives the randomness basically. 0.7 is more balanced. Anything more than that, I think anything more than 1 will give more hallucinations. But you can test it out. Some people say they like it at 1.2 or even 1.4, something like that. So it's up to you. Next, we have top P, which controls focus versus diversity of responses. Then we are setting stream to true so that we can get the streamed data. And finally, the stop, which tells the API that what sequence will end the response. Alright, now let's have a look at the stream processing. So this is how it basically works. We get a reader from the response body. Then we read the chunks of data as they arrive. Then we'll decode the bytes into text. Then split into new lines. So each is a complete text, basically, message. Then we'll parse this data from each line. And then we'll extract and clean the AI's response. And finally, we'll send it to the front end via our stream. Might sound confusing, but if you just have a look at the code and just go over it, it'll make sense. For error handling, we are using basic try catch error handling. All it does is it catches the API responses and sends it to the front end so that the user can see what error was there. And we have the response headers. In the response headers, we have content type of event stream, cache control to no cache, and connection to keep alive. And that was our backend. That's all that there is. It's nothing too complicated. Other than the streaming of events, maybe everything else is pretty simple and straightforward. You're just making some requests to an API and pushing the response from there to the front end. I'll leave the entire code in the description. There'll be a GitHub link somewhere. So yeah, that's it. Thanks for watching. And don't forget to subscribe because I'm going to be making more videos like these. And there's a lot of interesting ideas that I have in mind that I'd love to explore and share it with you guys.